Good morning, students. Today we will start with a new chapter, that is chapter 12, Understanding Quadrilaterals. In this in the previous classes you all have learnt about curves, open and closed curves, polygons, quadrilaterals, etc. In this chapter we will be learning the properties of quadrilaterals like angle sum property of a quadrilateral, types of quadrilaterals, properties of parallelogram, rhombus, rectangle and square. Now curves. Now you all know what is the difference between curve and a plane. Flat surfaces are known as curves. Now there are different types of curves. First is open curve. Means the curve which have a different beginning and end points. Okay, that is called open curve. Closed curves, the curves which have the same beginning and end point. So that is known as closed curves. Then simple curve, a curve which does not cross itself, is called a simple curve. Then, so here what do we find here? That this is an open curve. Then this is also an open curve. This is an open curve. This is also an open curve because it has different end and beginning point. Now closed curves are this second one, third, fourth, fifth. Okay, so these are closed curves, but these are not simple curves. This is not a simple curve because it is crossing, the lines are crossing each other. Similarly here, it is also not a simple curve because the lines are crossing each other. Then polygons, a simple closed curve made up of entirely of line segments. Means it does not have a circular curve, okay, curved part. Then it is called a polygon. It is made up of straight line segments. Okay, so these are called polygons. There are two types of polygons, convex and concave polygons. Convex polygon in which each interior angle is less than 180 degree. So each interior angle should be less than 180 degree. Then it is a convex polygon. Okay. Then concave polygon, a polygon in which at least one interior angle is greater than 180 degree. Means it is a reflex angle. Okay. Then it is a concave polygon. Another characteristic of concave polygon is that at least one diagonal should lie exterior to the polygon. Okay, so this is called concave polygons. In this chapter we will be learning only about convex polygons. In this chapter when we'll be speaking about polygon, it will be a convex polygon only. Then regular and irregular polygons. Regular polygon in which all the sides are of equal length. Okay, so it is an regular polygon. For example, equilateral triangle. When we talk of a triangle, in this case the regular polygon will be an equilateral triangle. Similarly, a square. Okay, so it is also a regular polygon. Now you can see that ma'am, rhombus is also has also all the sides equal, but the condition for a regular polygon is that all sides should be of equal length, all interior angles should be also of equal value or equal measures. In rhombus we do not get that. Okay, all exterior angles should be of equal measure and all regular polygons are convex. Then irregular polygons, a polygon which is not regular is called an irregular polygon, like a rectangle. Here only opposite sides are equal. Okay, so it is a irregular polygon. Similarly, rhombus, though all the sides are equal, but the angles are not of equal measure. Okay, so this is also an irregular polygon. Then sum of measures of all interior angles of n-sided, means if it is a 3-sided, 4-sided, 5-sided, in that case n will be 3. If it is a 3-sided polygon, 3. If it is a 4-sided, in place of n you will write down the number of sides, is equal to n minus 2 into 180 degree. Suppose I tell about a triangle. We know that sum of all interior angles of a triangle is 180 degree. So you can just put here and find out the value. And the number of sides in a triangle is how much? 3. So 3 minus 2 is 1. 1 into 180 degree is 180. So sum of measures of all the interior angles of a triangle is 180 degree. So the formula for finding the sum of measures of all interior angles of n-sided polygon is n minus 2 into 180 degree. Then each interior angle of a n-sided regular. Here we had found out sum of measures. Here each interior angle. Then it will be equal to n minus 2 into 180 degree divided by n. Okay. Then if a polygon has n sides, then the number of diagonals of the polygon will be n into n minus 3 by 2. Okay. The sum of measures of all the exterior angles of a polygon is 360 degree. So children, you have to make this table given on page number 211 in your maths copy. Now let us start with exercise 12.1. So some figures are given below. You can see the figures. There are 8 figures given. You have to classify them on the basis of the given figure, that which is a simple curve. Now what did I say? That in a simple curve, the beginning and the end points are different, isn't it? So you can see here first, second. Okay, these are simple curves. At the same time, the simple curves are do not just cross over each other, do not overlap each other, isn't it? The lines do not overlap each other. So first, second, third, fifth, and sixth, these are the simple curves. Then we come to simple closed curves. Now when simple closed curves are there, we will be simple closed curves means what? Which has the same beginning and the end point and do not overlap each other. Okay, so here third one is there, third, it is overlapping, so it is not there. Fifth, then sixth also. Seventh is overlapping, so it is not a simple closed curve. Then polygon is having a straight line segment, so these are not straight, they are curved, isn't it? So third and sixth. Okay. Then convex polygon means each interior angle is less than 180 degree, so it is the third one. Concave polygon, it is sixth one, because you see here one angle is more than 180 degree. Okay, so in this way we have classified these curves. Now question number 2. How many diagonals does each of the following have? A convex quadrilateral. So we know that we know the formula for finding the number of diagonals, that is n into n minus 3 by 2. Now if it is a quadrilateral, means the number of sides are 4. So just put the value of in place of n you will write down 4. So 4 into 4 minus 3 by 2, that is equal to 2. So the number of diagonals of a convex quadrilateral is 2. Okay. Then second is a regular hexagon. Again, what is n here? N is 6, because you know in a hexagon there are 6 sides. So just put the value into n minus 3 by 2. You will get the number of diagonals as 9. Now come to question number 3. Find the sum of measures of all the interior angles of a polygon with number of sides. So I'm doing the first one for you. Second one you will do on your own. So n is equal to 8. So just put the value, sum of all interior angles is n minus 2 into 180 degree. N given here is 8. So 8 minus 2 into 180. 6 into 180, that is 1080 degree. Second one you will do on your own. So children, for today this much only. Thank you.